So my project was on magnetic accessibility of the 2D antiferromatics with the chloride, alpha chloride. Um, some things to be aware of in this project is the magnetic accessibility, which gives off if the X is negative, then the magnetic field will be weaker. But if the X is positive, the magnetic field will be stronger or strengthened. Magnetic field with that is B is a vector field that describes the magnetic influence on moving electric charges, uh, electric currents, and magnetic materials. And some part of that is B field, which is the force of a moving charged particle. Magnetization, which is M, is the total magnetic moment. J, which is I'm holding constant here, is a spin interaction constant. And KBT in this project is essentially temperature. In the project, this is the code I use pretty much. I held J at 0.001, and the values of K I had were at 900, 600, and 200 Kelvin. When I used this for 900, 600, and 200, I found with the magnetization versus the magnetic field, with a decreasing temperature, the magnetization resisted, which can be seen in the 200 more clearly, and the slope got even steeper to reach the low part of the magnetization even sooner, since it's around 2,900, around 1,500 and 600 Kelvin, and it's at 1,000 when it's at 200 Kelvin. It's something similar when it's the accessibility versus the B field spin coupling ratio, but in the parabola, in the 900 Kelvin, the accessibility goes down to a little under 2. Wow. And it's at the B field at B, and it goes back up. 600 is lower than -2 and 4. And there's it's similar to the 900 Kelvin one. Other than that, but the 200 Kelvin one, there is a lot of resistance to wanting to go downwards, and it's much lower than previous ones. And there's a odd value out right at the top, right there, which makes the graph a little bigger and wonkier. And pretty much the decreased temperature leads to increased resistance of the magnetization. And this is with the J being greater than 0. And that is all I have. Is there any questions?
Unmute and let's clap once again. Okay. Any questions to Tyler, or questions, or maybe just comments of how you impressed, or if you see any scientific value or like paradoxes posed or resolved? Any comments or questions in class? Any comments or questions online?
I do.
Yes, please.
Just have one. So I noticed that on the slide we're on, for the temperature 900 and the temperature 600, is the orange the fit and the blue the actual data points?
Yeah, it looks like the blue is the actual data point because but the fit and actual data points are so similar on 900 and 600. It's only going to
Orange
tell
is
that they're different in the 200.
Okay, so I guess my question, it looks like on the 200 Kelvin, the orange is a little stepwise. Do you think that's just because of the randomness of the blue points kind of evening out, or do you think there might be something more there?
From what I can gather, it is just the randomness of the blue points. It is a lot of it. It's in every 200 graph I've found that there's a lot of randomness going on.
Okay,
So-
thank you very much.
any more? Steven, do you have any comments? So let's keep this problem a little bit. So Tyler partially addressed it, but we can keep it partially open to next year class. So you see that for temperature 200, the slope from 0 to, let's say, 300 Kelvin is almost 0, right?
Yeah.
Which in previous talk by Payman, in order to achieve 0 slope of magnetization to magnetic field, one needs to increase temperature. Here it works otherwise. You decrease temperature and you get 0 slope. So definitely there is something non-trivial. And Tyler partially addressed it with verbal language of system is resisting to external attempt to change its magnetization. Okay, with this, let me thank all attendees, all presenters, all attendees, all who asked questions, and all who provided maybe questions and improvement suggestions in secret, or provided some materials for all of us, like Steven. We will depart in and finish in a minute, but maybe since Payman reached us, we can do one more high resolution photograph, maybe with a cell phone, and everyone will get very strong credit for this presentation because you did something outstanding, and when you will learn about it, you will not regret. Okay, thank you everyone. I'm clapping mentally, and I just my hands are busy with holding camera, but thank you everyone.